Hello and welcome to the latest 60 Minutes web seminar from BIC Instruments. My name is John Kowalski. I'm part of the marketing team here at BIC Instruments and like to welcome you. Today we have our topic, Fundamentals of Protective Coatings Inspection. Our presenter is Mr. Matt Feit. He is our business line manager of protective coatings and resident coatings expert. Also, we make this as interactive as possible. If you have any questions, please log them in the chat and I'll jump in and ask those to Matt. And if need be, I may ask you to unmute yourself as well. And we can carry on a conversation that way. A lot of times people get tired of hearing me talk. And so the more the merrier. We are also recording this. And immediately following the presentation, you'll receive an automatic or an automated marketing email with the link. Feel free to share it with colleagues, save it for later. Valentine's Day, so maybe it's a hot date night. I don't know. But do what you want with it. But the information's there. So with that, I think we will kick off. Matt, it's all yours, sir.
Hey, thanks, John. And, happy Valentine's Day to everybody. I know it's probably a great day to talk about coatings and inspection and equipment. So yeah, let's jump right into this. All right. So, as most of you, if you're attending this webinar, you have some form or some interest or some role in the protective coatings industry. Maybe architectural coatings as well, because I mean, it's still the same concept. You're still using a coating to protect the substrate, whether that's steel or wood or concrete or drywall, right? So, today's modern coatings, as we now know them, one, most people think they're there for for color and appearance, but it still is the true protection of the substrate from corrosion. The color and gloss is the appealing portion of the system, but the function of the coating in and of itself is protect the substrate. Like I said, whatever it is, steel, concrete, wood, plaster, pretty much anything that needs a coating for protection. So for the topic of this discussion, we're going to talk about carbon steel, most typically hot rolled carbon steel. And if you think about what steel is, it holds up our office buildings, the bridges. Depending on where you live at, there may or may not be a sore spot or a discussion point. But anything, hospitals, stadiums, schools, water tanks, wastewater, anything, everything is kind of built around carbon steel. And the most persistent and natural threat to the steel and our internal structure is corrosion. So I mean, I think everybody's seen the great videos or pictures of the blast ovens with the looks like molten lava, which is the steel being forced into a large amount of energy. Tremendous amounts of high temperature and energy to make it from its natural state into carbon steel. But the reversal of that process, which we're going to call corrosion, it really doesn't take a lot of time and effort. You need an electrolyte, an anode, a cathode, and a pathway, an electronic pathway. So with all the effort that goes into making the product, it really doesn't take a lot to revert it back to its natural state.
Okay, quick question, Matt.
Yeah.
How long does it take? I know there's lots of variables, what's in the air, humidity, if it's, sea air, but, if you're by the sea, direct sun. Is there I guess, a rule of thumb of how much or how fast something will corrode if it's not properly protected?
So you just kind of hit it right on the head, John. It is very dependent on the conditions that the steel is going to be in. whatever in a caustic manufacturing environment with chemicals and whatnot, that steel is going to corrode a lot faster, which makes sense, right? Than say, a piece of steel sitting out in the middle of the Midwest where it's a very dry, arid type of environment. So the amount of deterioration of that steel is extremely dependent on the service situation that it's in. So
Gotcha.
there's
Okay.
there's no real you can just look at it one way. One, caustic environment will obviously corrode a lot faster than a you know
Yeah.
sort of a more mundane situation.
Okay. We have a quick question in here from Larry. Which is the anode and which is the cathode?
Which is the anode and which is the cathode?
Yes.
As far as we're talking about the I have it here. Hold on.
Are we getting to it?
Yeah, we're gonna get into it in a little bit.
Okay. Hold tight, Larry. We'll get to it.
I believe we have some slides on the battery cell. All right.
All right.
So many products and processes are used to slow down corrosion, but for the point of this discussion, we'll talk about protective coatings, and they are referred to typically as barrier protection. Other inhibitors, rust inhibitors, can be added to the coating, or incorporating zinc basically turns that coating into a sacrificial coating that's going to corrode first to protect the steel that is painted. All right, so coatings have been around a long, long time. And as much as stuff has evolved over the last 30, 40 years, there's new nanotechnologies and everything that are still evolving today. I think it is one of the most heavily invested upon industries as far as R&D processes are concerned. And a lot of that is driven by regulations, VOC compliance, lack of old materials to build the coatings, formulate the coatings. So that's going to be at a continuously market for probably for as long as the rest of us are around. And it must be noted that there's not a single coating or system that can provide protection forever, or more importantly, for all service environments. We talked about earlier some less corrosive environments. You're not going to want to put a high price tag epoxy coating system on that. It just doesn't make sense. So each different environment's going to get each different product recommendation. And there's a lot of R&D folks that work at these major coating manufacturers. That's what they do all day long. They're testing products from day to night, trying to come up with the next greatest thing. So when we're talking about a coating system, it has a beginning, a middle, and an end. That's the product life cycle for those of you familiar with it out there. And monitoring, you just don't walk out to a job, prep it, paint it, walk away. Proper coating system is going to have to be monitored. You're going to look for mechanical damage. You're going to look for anything that could be going wrong on that system. A maintenance program is probably going to be your best bet to keep that system, which you more than likely paid a lot of money for, performing well and extend the life of that system. So, and I'm not a coding consultant, but there's probably some individuals on here that have worked, in the industry, and there's programs drawn out there that you can put your environment, you can put your system, you can put a whole bunch of data into, and they can basically tell you or anticipate the useful life of a coding system. So that helps for budgeting, that helps for large planning, depending if you're like a DOT or even a government organization. It's basically what I was just talking about. If a system has been designed and tested, an expected life may be 15 to 20 years, if adequately maintained, as I said a little bit earlier. If something is to go wrong before that, exponentially before that, it's called premature failure. So getting into a little bit about, once again, I'm not a consultant, but we will talk about what could go wrong during the application process of a coating system. And if you look at this chart right here, we're not going to dive too far into it, but look and see, I've heard numbers from 60 to 80%, but poor surface prep. Poor surface preparation is going to give you that insufficient bond profile. If your coating system is calling for, a 3 to 5 mil profile, but you don't hit those, you don't hit those numbers. You're light or you're heavy. That's going to mess with the um, performance properties of the coating. And in most of the coating failures that you see in one form or another, you usually can go back and whether that's surface contamination, abrasive embedment. There's all kind of different things that can go on, but it's usually improper profile or improper media was used. You should have used a grit, but you used a shot abrasive, whatnot. Crazy number, really. All right, so what happens? How do we come up with a good coating project? So we talked a little bit earlier. Proper specification for the environment. We'll get into a little bit about ambient condition monitoring and whatnot later, but atmospheric conditions have to be within spec for what the coating manufacturer recommends. Already talked about surface prep and proper application equipment. I guess we could call that, whatever your means of abrasive blasting is, and then applying the coating in and of itself. And more importantly, you gotta have well-trained laborers. I know we deal with a lot of cutting applicators, and as the years go on, you always hear them complain, and it's harder and harder to find good skilled trained laborers, and that could lead to another greater discussion about training programs, etc. Quality control and quality assurance programs will definitely specify what is a QC and what is a QA role. And on the back end of it, a well trained and ethical coding inspector or coding inspection firm. Everybody gets a little nervous when you talk about coding inspectors being on a project, but for the most part, people aren't there to just to make life miserable. A good back and forth, a good interaction, good communication between inspection firms and contractors and owners. I mean, it's there to make the job go better and last longer. Then on the back end, something near and dear to my heart, well maintained and properly calibrated inspection equipment. You know, a lot of people want to go, well, I didn't use my gauge that much. Why do I have to send it in for annual calibration? Well, you don't. You really don't. But a lot of these firms and a lot of these contractors do have QC documents that recommend annual calibration. And some of the equipment, some of the ambient condition equipment, they drift. You want to make sure that you're accurately checking and maintaining those specific gauges against known calibration standards. Very important. All right, so we're not gonna hit on all of these learning outcomes today, but we're gonna talk about the differences between QA and QC roles. We kind of will talk about the twofold process of surface prep. Using a Viz guide, SSPC Viz guide is very important. Ambient conditions. I will talk briefly about calculating wet film thickness. It's a seems to be a fairly simple process, but a lot of people, either forgot it from their training or could just use a refresher, right? We'll talk about the two different types of dry film thickness gauges. And, like I said, we'll talk about verification versus calibration. It's a very hot topic in darn near every conversation or training class I've ever been through. What are pinholes or holidays in a coating? And real briefly at the end, we'll talk about methods to evaluate coating adhesion that are typically used in lab and more importantly on job site, in job site settings. Sorry. So we've been talking about this word corrosion here for a little bit, but is defined as the deterioration of a substance, usually a metal, or its properties because of a reaction with the environment. So in a coating application, obviously you want to limit that, steel's reaction to the environment. It's a natural process. This is basically the tendency of materials to give up energy and head back to their natural state. Discussed earlier, it takes a tremendous amount of energy to convert materials found in nature into usable materials for construction. But it's going to convert back quickly. It's going to rust. It's going to corrode. It's going to look bad in a short amount of time, depending on the surface environment, if it's not protected. So protective coatings are the most widely used method to prevent corrosion on carbon steel. We had a question earlier about cathodic protection. What is a cathode? What is an anode?
Yeah.
I think more and more, especially on pipelines and other applications, individuals are specifying cathodic protection with a superior coating system to even extend the life of that asset longer. I'm
Yeah.
not an expert in cathodic protection, but I've been exposed to it enough and different means and methods of testing it, and it does seem it's been around for a little while, but I really believe that that's the way of the future.
Hey, do you mind if I share my screen real quick? I pulled some stuff out of our dispersion and milling presentation on
Sure.
energy
Yeah.
storage. So let me pull that up for folks. And let's see. PowerPoint. I think it's, for some reason, I can't share my screen. Okay. Well, that's okay. Let me make it as an attachment and put it in the chat for everyone. There's basically two slides that show, visually what the cathode is. Negatives the cathode, positives the anode, and then I have a slide that's text that basically describes that the electrolyte in a battery, this example, is a substance that allows ions to flow between the anode and cathode.
Yeah.
Electrolytes.
So
Go ahead.
think about it this way, John. The anode is the part of the cell, the corrosion cell, that deteriorates.
Okay.
So if you're ever been on a pipeline or whatnot, they'll toss the anodes and tie them into the system on the ground, and those anodes will corrode underground before the corrosion will get to the pipe. So the
Got it.
anode does give up the energy, and the cathode is, what they're trying to protect.
That sounds good.
All right. So industrial, like we talked about a little bit earlier, industrial coatings have been around for a long time, the 30s. But during World War II, the need for formulations definitely increased, and the polyamide epoxies, they offered excellent excellent adhesion to a multitude of substrates. Some that may not have necessarily been prepared properly or to the greatest extent of, say, an SP5 white metal blast. Laughing because I'm probably sure they didn't even know what that was back then, but they really took off during the war efforts. All right, carbon steel. We can look at iron since it's basically the component of the steel that does corrode. It's composed of iron at concentrations of 95 to 99% by weight. I'm not sure where we pulled those numbers for, but that sounds fairly close. Different types of steel have different percentages. And, the terminology of carbon steel, that's when you're adding carbon to the mix to increase the strength and add other desirable properties. Other steel alloys can be produced by adding copper, chromium, nickel, and phosphorus. And just adding, while adding these elements, John, it's very expensive. That's why you're looking at it going through the whole coating system process. But adding these different elements can very highly reduce the rate of corrosion in specific alloys.
Okay. Got it. That makes sense. And if anyone has information on the anode cathode thing, I did upload the two slides in the chat. You'll see a little PDF icon. Feel free to look at those or download those for more information. All right. Sorry to interrupt, sir.
Oh, no worries. No worries.
Yeah,
So
and
you
I
really
mean,
can't.
if anyone else has questions too, please, log them in. We'll get them in. We want this to be as interactive as possible. I did get a question in here. What do you, two questions. How do you prep the surface if rust is always already there, or
Mhm.
what do you do if rust is already on the surface? Kind of a tie in there.
Yeah, sure, no problem. So if you're talking about overall, you know, maybe like a spot rust type of situation,
Yeah.
there's different means and methods. You don't necessarily have to pull out a large blasting unit. There's different handheld instruments, rotary blasters, or um, gauges that'll take that rust off and bring back out the original blasted profile. So there are ways to uh, prep areas that just need touched up. But typically, I mean, if you're going through the process of, say, repainting the outside of a water tank, and there's a fairly decent amount of corrosion, prior to blasting, you're probably going to check for soluble salts, salt content.
Hmm.
Depending on where you're at, what part of the country you're in. I've always been a firm believer. I don't really care what type of salt it is on the surface. You got to get it off. So there's different means and methods like Bresley patch methods, etc., that you can test the surface. If it needs wash, then you power wash it down. A lot of products are made for different companies like Hold Tight, a couple other chlor wash, that'll help you hold the surface from further flash rusting prior to blasting. But basically, you check the surface for contamination. If there's contamination present, you get it off, and then you can go through with your prep.
Got it. Sounds good.
Yeah, so it's either hand tool cleaning or abrasive blasting. That's the two biggies in that world. All right, so basically, we want to slow down the process of corrosion, and coatings function in basically three different ways. We talked about barrier. We talked about sacrificial. That's going to be your zinc primers and whatnot. In the protective coatings world, I mean, zinc epoxy urethane. I think most architects or specifiers come out of school. That's kind of what they say. Zinc epoxy urethane. And then obviously adding inhibitors to the coatings themselves. We talked about barrier protection. I'm not going to pretty much go over it, but basically it prevents the air and water we've talked about a few times, which is necessary for corrosion from reaching the substrate. Kind of hard to see this graphic down here unless you can blow it up, John. This is a pretty cool example. MIO or aluminum flake coatings. Uh, Actually, there you go. So the internal ways that they make these things, they actually form like they look like plates, and they layer over top of each other, and that basically makes that moisture take a longer path to get to the substrate. So it's not a you know it's not something you see on an everyday basis, but there are different coating applications that really do slow down the corrosion process.
All right, let me get you back to
Yeah,
normal
but
size.
I didn't need my readers on that one.
Yeah, there you go.
All right. So so what is the process of coating inspection? We're talking about corrosion, we're talking about coatings, we're talking about different equipment. Um, but I want to get in real quick as to what is the difference between quality control and quality assurance. So overall, you know, quality is defined as the characteristics of a product or service that basically gives it the ability to, this is kind of worded long, satisfy stated or implied needs. Let's just say it gives it the ability to meet the project specification. Okay. So how do you ensure, or how does the contractor, how's the owner ensure that that coding system is going to meet the specification? Well, there's two different roles: quality control, QC. This is the contractor's responsibility, and it also always involves specification. Following the specification for ambient conditions, profile, making sure the equipment is up to standard. What was Was the coating induced properly? Meaning, was it mixed together at the proper temperature, let sweat in, and then used within the pot life? So there's a whole myriad of checkpoints that need to be performed on a daily basis. And in an old life, we used to say you literally stand there, you're watching the paint dry. I mean, it's this. Not real sure, but this may or may not be where that word or that
Yeah.
term actually came from. So, QC, it's verifying that the contractor is doing the job right. Quality assurance. So quality assurance is usually the role performed by the owner or by the owner hiring a third party inspection firm. Uh, so a QA inspector verifies that the quality of the work performed by the contractor and what is being reported by the QC inspector. So, a lot of times there's a little bit of strife or a little bit of back and forth, but QA and QC inspectors should be working together, to make sure, that the job is going smoothly.
We do have a question here. Which is the best protective coating, and which has the best service in hot or a climate like desert?
So we could take this offline, John. I mean, I don't want
Yeah.
to really talk about specific coding systems, but we can certainly get that information out.
Okay.
Just a quick answer. If you're out in the desert, chances are you don't have a lot of other issues going on there. There's probably not a lot of salt. There's probably not a lot of chemical contaminants on the surface. With an application like that, if they're talking about a pipeline or whatnot, they may be looking for more of a color and appearance, UV resistance. I don't know, but
Gotcha.
get their information and we can definitely talk about that offline.
Got it. Yep. Thayer, we'll do that. We'll contact you directly
Definitely.
following this
Yeah, not a
presentation in the
problem.
next couple days. Okay.
All right. So, what is the role of an inspector? OADR: observe, assess, document, and report. And this is where sort of. I'm not going to dive too far down the rabbit hole, but this is where a lot of when people are talking about inspectors kind of gets a bad name. You're really not there to interject yourself into um, the actual project itself. You're there to interject yourself if you see something going wrong, or if you see results going wrong. That is your job to report and discuss. But a lot of times people get a bad taste in their mouth for an inspector because they feel they're going above and beyond what their roles and responsibilities are. So this clearly defines, you're there to observe the contractor. Even, if you even work for the contractor, that's still your job is to make sure everything's going right. It doesn't meet the specification and document the results, which, may or may not be needed to pull out at a later date, if there is a premature coating failure, etc. And, you report what is the progress and quality in relation to the specification. So, it might be weekly, bi-weekly meetings, whatever the case may be.
Mhm. Gotcha.
All right, we're going to hop into prep real quick. We talked about it twofold earlier. There's a question about, easiest way to remove rust. As you can see here, there's a gentleman out there power washing away. Probably looks like that's on the underside of a bridge overpass, if I'm not mistaken. So you're gonna clean the substrate and then you roughen the substrate. That's pretty much the main goals of surface preparation. Um, Obviously by that failure rate, quite a few slides back, preparation is still recognized as the most critical step for coding project success. And most of the experts, I'm sure a lot of individuals on this call, say the final prep of the surface is going to determine, you know, the service life of the coding system.
Yeah.
Uh, Even if you got great prep, if the surface is ready to go, even if it's a bad recommendation as far as a coding system, you still may get some life out of it.
Mhm.
And in the middle here, it's going to be an SSPC Viz guide. So after you clean, Then you're going to abrasive blast the surface, and you use your visual guide in the middle to verify or compare that the blast meets the specification of the project. And the right hand side is just a close up of what we talked about, grit. This is angular grit abrasive.
Uh,
So if you look at that, that's going to give a real, and there's a couple slides on it in a little bit, but that's going to give the profile of the steel a real toothy. People talk it, the profile has teeth. You'll hear that terminology a lot.
so you mind popping back real quick?
Yeah,
Um,
yeah.
Now, do you take a measurement at all before you blast and then after, or is it simply you're blasting off the corrosion and
Mhm.
um, looking to measure, like that middle slide? So, or are you just measuring after the fact?
So you're going to measure after, say you're going to do a span of 30 feet, whatever, whatever the
Okay.
case may be, whatever you can do during one work shift, right?
Yeah.
So you're going to check for salts. You're going to do all that stuff we talked about earlier. Then you're going to blast a specific area. Then, you may even use, as you're blasting, you may use a simple tool like a surface profile comparator. Just pull it out of your back pocket and say, hey, yeah, it looks like I'm in the right range of my anticipated profile. And then typically at the end of a work shift, somebody's going to, pull out their digital depth micrometer or their replica tape. And that's where you actually take your profile readings.
Okay.
Um, it's going to vary from project to project, but you obviously wouldn't want to, common sense would say you wouldn't want to blast an entire bridge and then check. You're going to want to do it in incremental steps,
So you're
basically.
measuring and checking along the way.
Yeah, yeah. So if there is a problem with a profile, or there's something wrong with your compressor, or your abrasive mix wasn't proper, uh, you're not going to do too
Mm.
much work before you would have to go back and redo it.
Got it. Got it. That makes sense. Thank you.
Yeah, no problem. All right. So what all goes into important inspection points during surface prep? We talked about ambient condition, cleanliness, and profile. So if you're in the industry, or common sense would say if you ever gone golfing or fishing in the rain, you kind of know what that feels like, right? No different from a coating project. You're gonna want to know the conditions: air temperature, moisture content, which is relative humidity, and that temp at which the condensation will occur on the steel, expressed as a dew point. Um, you know, Most paint specifications, in fact, if you're ever at a pre-job meeting and you don't see anything requiring ambient condition monitoring, you better put your hand up real quick, because it could get into a world of hurt there. But you're going to look for surface temp and specific threshold for air, surface temp, and relative humidity.
Okay.
And this says all coating manufacturers should have their condition requirements on their product data sheet. And quite honestly, John, most of them have them on the can. It's going to be in
Okay.
a little
Yeah.
small portion. It'll give you your application notes, the anticipated wet film, blah blah blah. But it better have some ambient condition requirements as well.
Okay. Now, is got a question in here too. Some applicators and contractors um, have applied new coatings on surfaces. Let's see, are applied on new coatings on surfaces and have corrosion. They do it without cleaning. Does that affect the life service of the protective coating? And I assume yes. I mean,
Oh,
if you're not
absolutely.
cleaning it and preparing it, it's probably voiding the warranty.
Well, yeah, and I mean, if you're talking about warranties on coatings or warranties on project, that's we're talking a whole different animal there. But
Yeah.
yeah, I mean, just because something came new from the manufacturer, I mean, think about it. It's getting shipped, it's getting trucked, it's getting boated from somewhere. Floating on a boat coming across the sea.
Yeah.
That's typically where a lot of salt contamination comes from. So if they're
Mm.
if they're not at least checking,
Yeah.
If you're telling me that they check for soluble salt content prior to putting on a new coating, okay, maybe I'll buy that. But I would think any contractor is going to want to have some sort of a process in place to verify the cleanliness of
Yeah.
that new. Even if it's new, you still want to make sure it's clean. So yeah,
Yep.
that would highly affect the performance of that coating.
Yep. So you got stuff affecting the coatings perhaps, and if you're not preparing the surface correctly, that's a whole other issue. And you probably see, a ton of that out there. They wonder why things are failing, and then it comes to find out that they didn't prep the surface properly prior to applying that, application.
Oh yeah, yeah. There's a large, you know, depending on what side of the fence you're on, there's a large industry made from, there's I can't even tell you the amount of different coating failures that occur, but
But
you know, a lot of it is because of, you know, dirty, salty, bad
yep,
prep, bad profile, etc.
yep,
Uh, or if something could look good, but if you don't put it through, like adhesion testing prior to coating application, hey, we're just gonna repaint this. Well, you're really at the mercy of what that coating is doing underneath your new coating. So there's a ton of proper things that can be done to ensure you know good coating performance.
that's a whole other webinar.
Oh, that's a whole other animal, right? That's a whole other argument for a lot of people too, but that's the fun part, right? All
Exactly.
right, so we talked about it. You're measuring your air temp, RH, and dew point, and surface temp is also measured in a recorder. We'll get to some of the commonly used equipment here in a second. There we go. Good old analog sling psychrometer or psychrometers. Geez, I forget what the stat is. I wrote a paper on this years ago. I think psychrometers have been around 500 years. They found records of psychrometers, and they probably
Oh,
still work. To be honest with you, uh, when you're doing using a whirling psychrometer, you're taking your readings. You're letting the wet bulb and the dry bulb stabilize, and then you can see the blue psychrometric chart right there. There's a fairly easy process to follow to get your RH and dew point. On the right hand side, of course, is a digital hygrometer. Um, Hundreds of varieties out there nowadays. But the neat thing about a digital hygrometer, this is a positector, a DeFelsco unit. Once this thing stabilizes to the work environment, meaning if you're rolling up on a job site or production facility, you're jumping out of your air conditioned vehicle. You can't run right up to the job site and take readings. These things all have the same sort of, lack of a better description, Honeywell sensors in them
okay.
that need to acclimate to the area that you're taking readings. After that acclimation period, the cool thing about these, there's no interpretation. If your gauge in and of itself is in calibration, these readings right here, RH, air surface dew point, and the spread, that is automatically recorded. You can Wi-Fi that or Bluetooth it or plug it into your computer, and now you have a permanent record of the conditions of that work time frame. So it's pretty neat stuff.
Hmm.
Just some other commonly used items. On the left-hand side, you have magnetic surface temperature gauges. You can go through all the measurements for RH and dew point. A lot of companies will just slap these things on a substrate. It's going to give you an accurate representation. The middle, you have an IR gun, infrared laser gun, and on the right-hand side is typically recording measurements done in ovens and whatnot, powder coatings, or if you have a production line. This unit sits outside of your booth, and there's a bunch of little probe attachments that you can put all amongst throughout the booth. Yeah, we've mentioned the terminology surface cleanliness a few times, and these are two of the most commonly used guides have been around for 30, 40 years, I would imagine at this time. I think the original revisions were in the late 70s. Not the revisions, but the first models were in the 70s. But basically, the way this came about is a lot of the industry experts and leading minds in the inspection world came together and said, okay, we have all these different visual views of what should be a white blast, near white, commercial. And through a long, arduous process, they came and said, okay, this is the standard. This is what the industry, I'm doing air quotes, no, you guys can't see me, but this is the industry standard for which we're going to visually inspect abrasive blasted steel. That's a Viz 1 guide. And these are the industry standard as which we will inspect hand and power tool cleaning. That is the Viz 3 guides. If you're ever getting into the market, or if you ever have questions about, is my surface right, these are inexpensive. It's a great tool. You could quickly see if there is, if it's going to be within or without specification. Been around a long time, like I said. All right, we talked a little bit before about profile, and I did mention, John, if you could blow this one up a little bit.
Yeah.
All right, so profile, and this is visual representation um, of a surface prepared by grit. So profile is a maximum peak to valley depth that is created during the surface preparation process. I've said teeth, profile, anchor pattern is another big one. So there's many words that the industry uses to basically describe one thing, that is surface profile. So there's going to be a minimum and a maximum profile for each project, and I just have this one little representation. If you're reading the spec and it calls for a 3 mil profile, you got to ask for clarification. Exactly, it's like looking at a paint spec and they're calling for 10 mils. And I mean, it's unrealistic. There's always going to be a range, high and low. So if somebody's looking for a 3 mil profile, they probably mean 2 to 4. Making those numbers up, but I hope you guys get the point. The factors affecting the depth. We talked about this a little bit before. What type of the abrasive, the size of the abrasive, and as well as the hardness of the surface being prepared. You might, if you're just looking for a low profile, use a smaller abrasive and use more of a sweeping type of an application, or a deeper profile. If you're getting into the metallizing coatings or whatnot, you're going to be using a large, aggressive abrasive. But you can see what, when you look at a piece of blasted steel, it looks very clean. It looks very uniform, nice gray, no shadows or whatever. But this, when you get a magnified view and when you take your profile readings, this is what it's telling you. I mean, it's an aggressive looking animal there.
Mm.
All right, so we've been talking profile. So how do we measure profile? Um, Method A of D4417 we talked about briefly a little bit ago. I said, hey, if I'm hanging off the side of a bridge or hanging off the side of a tank, and I'm a blaster, I want to make sure I'm in the right profile. You're going to pull out these surface profile comparator discs with a 5x magnifier. You basically put it up to the surface, and they're on each one of these discs, each one of those fingers, for lack of a better term, has its own replicated profile. So you can say, okay, I know I'm in between my 2 to 4 mil profile. Everything's good. I don't need to change my setup. The abrasive's good. The pressure is good. The nozzle is good. Just keep on going. Method B of D4417, surface profile depth gauge, digital depth micrometers, they are referred to as well. Much like the digital hygrometer we talked about a little bit earlier, these digital depth gauge are going to give you, it's going to give you a documented history of that area that you're measuring, and it basically just works by putting the gauge itself, the bottom foot there, onto the surface, and there's a little itty bitty needle that goes down into the depths or valleys of that profile, or could hit the peak of a profile as well. And then it gives you your measurement readings. Method C, been commonly used for decades and decades. It's going to be spring-loaded micrometer with replica tape. So basically, what you do, you have your little piece of white replica tape right there, and you're going to put that on the surface, and you burnish. That's a burnishing tool. People call them swizzle sticks or whatever. But you burnish the center of that tape until it is a nice uniform gray color. Okay. Every piece of tape has a 2 mil mylar film attached to it. So when you're using your depth micrometer, or your depth micrometer, when you're using your Testex micrometer on the right hand side there, say you get a reading of 5, you always deduct the 2 mils, and that's going to give you your replicated, as you would say, surface profile. Or a lot of times, an inspector will just turn the gauge back to 8. It's going to be on a scale of 0 to 10. You turn it back to 8, and then don't have to automatically, you don't got to worry about trying to deduct it yourself.
Hey, while you're on the slide, we have a question from Larry. When would you use method A versus B versus C? Wouldn't you always want to use B if possible?
Yeah, that's a great question. Like I said, method A is just going to give you a spot check. If you're working through a project or whatever, you just want to make sure you're in the right range prior to completing whatever work you're doing for the day. So method A is strictly subjective visual method. Okay. Method B, you would think you would always want it to use because that's going to give you a documented result, right?
Right.
I'm using a calibrated gauge. I know what my readings are. I forget what PA 17 says now. I think it's you take 10 readings per the area, and you take the average. I'm probably going to get yelled at for that, but I think that's the way it still is. Method C, the reason people still use Method C, Larry, is because it's been written in specifications for 40 years. People are very hard to change. It is an inexpensive test. Um, and believe it or not, those little pieces of replica tape, once you adhere them to your quality reports, those things can be pulled out and put on a mic 20 years later, and they still read the same profile. It's really quite an impressive little piece of information. And the reason they still use Method C as well is because a lot of people don't trust the technology. That electronic gauge, give me my piece of replica tape, and I'll take my readings and do my averages, and we can all move on. So it's kind of method A is just going to be a visual method to keep yourself in check. But you do see method B being written into specification and being asked for by asset owners a lot more.
Yeah, it makes sense because you have that
Yeah.
data trail.
Yep. And method C has just been around for so long. It's just what everybody does. you know.
Yeah, that's what Grandpa did. Um,
Right.
Question here, and this might have been on the previous slide. Which is better to use in protective coatings, inhibitors or sacrificial elements?
Well, that all comes down to the environment.
Got
We
it.
we talked about earlier. A typical bridge system is going to be a zinc epoxy urethane. But if you're getting into some caustic chemical plants or whatnot, um, you know, I mean, geez, I'm by far and away not the coating expert, and there's probably 5,000 different formulations that you go from Carboline to SW to PPG to whoever. They're all going to tell you another thing, but the reason you use one above the other is just specifically the service environment, and that's
Got
kind of
it.
the most simplest way I can put it.
Yeah, makes sense. Okay.
All right, real quick. I know we're getting up against it here, but this is always a fun one to talk about. Because it seems like such a simple process. But learning how to calculate wet film thickness and using it as a inspection tool on a job can really help save you a lot of time and effort and money in the long term. What do I mean by that? So specifications always indicate the dry film thickness range, right? You know, you're gonna, like I said before, depending on what the primer system is, what the top coat, blah blah blah. It's gonna say I need a total film thickness of 20 mils, whatever. We'll make that number up. But unless you're using 100% solids material, you know, it doesn't. Many specs don't give you the wet film thickness of the coating to be applied. So if I'm trying to achieve an anticipated dry film thickness, it's always great to know as I'm applying the coating, where do I got to be at with my wet film to make sure I'm going to hit my dry film. He said the worst thing that can happen on a coating project or even in a manufacturing setting is you go through the whole process, you use a lot of paint, you use a lot of labor hours, and you say, oh no, I have to go back and do it all over again. It's called diminishing margins, I think, John. You're the marketing guy. I'm not quite sure what that is, but
That
you
sounds
get the
good to me.
yeah, right, right. So formula A, all right, with no thinner added, you have your anticipated dry film thickness divided by the percent volume solids, and that's going to give you your wet film thickness. So basically, if I'm looking for a dry film thickness of 5 mils and I have 50% volume solids coating, what do you need to apply the coating at wet to get to 5 mils dry, John? Put you on a spot here. It's a pretty easy one.
Say that again. I was answering a question. I'm
All
sorry.
right, so I'm gonna jump ahead. So if I'm looking for a 5 mil dry film thickness and I have a 50% volume solids, which means 50% of whatever is in that gallon is
Yeah,
evaporating, you're going to want to shoot for a 10% or a 10 mil wet film thickness. That
got
makes
it.
sense? It says
Yeah.
50% of the volume solids will be left on the surface. That's easy, right? That's
Uh-huh.
easy to think. But 95% of the time you're talking about industrial coating, there's going to be solvent, thinner, whatever you want to call it, added to the coating system prior to application. So how do
Okay.
we figure out that? All right, so you take the percent of the volume solids and you divide that by 100 plus the percent of the thinner added. So
Okay.
say it says, 10% thinner, 10% thinner to be added, per kit, whatever. That's going to give you your adjusted volume solids. So the dry film then is interpreted, well, you know the dry film where you're going for. So you take the DFT, anticipated DFT, by the adjusted volume solids, and that's going to be what the wet film thickness is that you're shooting for. Okay. So I'm not doing the math off the top of my head, but so if I add
Okay.
10% thinner, let's just say instead of 10 mils wet, I want to go 14 mils wet. Okay. Because there's additional, the thinner is going to reduce that total system. So you're going to add more wet film thickness to get the targeted dry film thickness.
Got it.
And there's just a good happy little picture of sound like Bob Ross there. Happy little picture of a wet film gauge. So real simple to use these things. You add the tip, you add the range that you're using perpendicular to the substrate, and you remove the gauge from the film. The last tooth that has coating on it, that is your wet film thickness. Okay. So, nice little picture there. If I'm measuring in the range of 4 through 10, and all the teeth, even the end pieces, have paint on them,
Yeah.
you flip, then you go to the next scale. Okay. So you would take it over to the next scale until you find where there's one tooth in that range that has coating on it. And that is your wet film thickness. That's it. That's how you measure wet film thickness. All right. DFTs, dry film thickness. Um, so the Minimax dry film thickness, or DFT, for each paint layer, it must be noted, we're talking about dry film thickness. It is the film, the coating film that is above the peaks of the prepared substrate or profile. It's above the peaks of the prepared substrate. So there's two different methods to measure DFTs. By two different methods, we'll just talk about type 1, which is a magnetic pull-off gauge. These are manual gauges, no electronics involved. Historically been referred to as a banana gauge because they actually look like a banana. They're less expensive, less internal potential, less things to go wrong, and you know, but that's it. You're going to get your reading, and then you record it manually. There's no means or methods of digital representation. Second part of it, we talk about type two, which is type two digital gauge. Once again, if you're talking Fisher, Alcometer, DeFelsco, whoever, Cunix, they all have hundreds of different versions of these things. It's been all the rage in the last 20 years, I'd say. Trying to get faster readings, more accurate readings, versatile, meaning can it read ferrous, non-ferrous, get into ultrasonic gauges that you can read thickness on wood, concrete, plastic, depending on what industry you're in. Real big in the window and door manufacturer. Anything you can think of that has a coating thickness on it, in some form or fashion, there's going to be a way to measure it. Now, when we're talking about this, John, we're talking about type 2 digital gauges. These are non-destructive.
Hmm.
Um, I we could have tossed quite a few more slides in here about destructive film testing, but for the
Yeah.
point of this application, that's when you're talking about PIG, pig testers, took gauges. You actually cut down through the coating to the substrate, look through a magnifying glass, reticle, and you can measure the films individually that way. So that's very useful in inspection of failures, etc.
Hmm.
But real fast, when you're talking about industrial coatings, ASTM D7091, that's a standard practice for non-destructive measurement of dry film thickness to ferrous metals, and pretty much a guide that's been around for quite so many years, and it always is getting updated. There's always committees working on it, but you hear the questions. Well, how many readings do I take? Where do I take a reading? Why do I take a reading? Um, you know, can I just take one reading? Blah blah blah. So this was a committee that was put together a long time ago through SSPC. Now remember, NACE and SSPC are now combined for AMPP. But these still committees, I believe, still work independently on these things. So PA2, these are the procedures for determining the conformance of a coating thickness project. So, on any application, on most projects, you're going to have a variance in the coating thickness. Okay. So if it's a little bit light on this section, but a little bit heavy on this section, there's ways to say, okay, let's use our heads here. Let's not fail the entire project or make the work all redone just because we're off by a little bit. So that's the high level description of they came up with a process to say, is this good enough? And how do we get to that point? So it's a pretty interesting and extensive document. If anybody's ever had the pleasure of trying to navigate it, they actually give classes on just how to use the standard. So if that tells you anything.
Yeah.
All right, real quick, verification of accuracy. This is the terminology we talked about earlier. Gets confused, misused, in my humble opinion, a lot. I'm in the field. I'm calibrating my gauge. Nope, no, you're not. You're basically you're verifying that your gauge is accurate prior to every work shift. Okay. Now you're verifying your gauge accuracy by using calibrated standards, traceable standards, such as NIST plates, or everybody has their own coated thickness standards nowadays. But you're not on a Type 1 gauge. You're not permitted to adjust the gauge so the readings agree with the standard. Okay. Well, that kind of stinks. I don't think I'm off that far. So look at it this way. This is the means and methods to verify that your little banana gauge is working properly. You take the square root of gauge accuracy squared plus plate accuracy squared, and that gives you a combined accuracy. So if my readings are within 7%, if the coating thickness standard has a stated accuracy of 7%, the gauge has an accuracy of 7%, then you use that process above and you can come up with a combined accuracy of 9%. So if I'm trying to read a 10 mil standard If my banana gauge falls within 9.1 to 10.9, that gauge is considered within range. Go ahead about your day, take your readings, take your measurements. If they fall outside of that range, then you're probably going to want to send it back, to a calibration lab or the manufacturer, because these things have to be adjusted. It's not as simple as a type 2 digital gauge. Real quick, hold on. I want to touch on this. I said this cannot adjust the gauge on a banana gauge. You are permitted to adjust the gauge with a type 2 digital gauge. Okay. So you're looking for repeatability. I zero my gauge, I take my reading on my 10 mil. It seems a little bit squirrely. I got a 9.2. Most of these gauges give you the ability to dial that thing up to 10, take another reading, and if you're within whatever the stated accuracy of the gauge is, if it consistently reads after your adjustment, then you are allowed to use that gauge. It is considered within tolerance. Okay, so there's two difference. The type 1 you can't, obviously, because it's a mechanical gauge. There's really nothing to adjust. But the type 2 gauge, per the standard, you are allowed to adjust it and bring it back into tolerance. I just want to make sure I touched on that, John.
Nice. Appreciate that.
No problem. All right, so getting towards the end here. Holidays, voids, pinholes, they're basically just skips or misses in the coding system. And these are very important, obviously, in certain applications, because that's going to give easy access to the elements we discussed before to get to the surface and cause premature corrosion. Very prevalent, and this is a very commonly used test. High voltage holiday detection is very commonly used out there on our wonderful pipelines and whatnot, because you don't really see what's going on with that coding system after it gets buried back under the ground. That's where we're talking about, the use of cathodic protection systems and coatings to help monitor the situation. Like if you have a big void or damage to your coating system, the cathodic protection systems are made to alert you. Hey, I'm getting a spike in the readings over here. But it's very commonly practiced to do it before you backfill on a pipeline. You want to eliminate as many holidays as possible. So holiday detection is typically performed after the final coat, but before the coating has gone to complete cure. So if a coating is completely cured, then you're talking about a whole nother process of abrading the surface and yada, yada, yada. So you want to make sure that you can do the repairs within the recoat window. So there's two different methods. You have your low voltage, or what's considered or commonly referred to as the wet sponge tester. And these are typically used on coating systems less than 20 mils. And you have high voltage detectors, which are called Jeep testers. They're typically used on coating systems greater than 20 mils. Now, coating manufacturers can recommend that you use high voltage on coating systems less than 20 mils. But man, I'm getting that in documentation. I'm getting somebody to sign off on that, because I've seen some damaged systems out there. So it's just another QC, and kind of down at the end of the rainbow for as far as inspection is concerned.
So
pretty much. Go ahead.
Before you move to adhesion holiday testers, it measures the skips or the misses in the system. Why the heck they call it a holiday? There's got to be a reason behind that.
You know what it is, and quite honestly, that standard, the NACE standard, has been around so long, I kind of forget. But I think what it was, and this is completely irrelevant to what a coding application really means, but I honestly think that people said the painter was out to holiday. I'm serious.
That sounds about right.
I've heard the old timers talk about it, and I think that's what it was. They had misses or skips or bad areas because they were out to holiday, meaning they checked out for the day or whatever. I think that's perfect. What it was.
Yeah, I'll bet you're right. That's awesome. Awesome.
It's just jumping to the front of my head there for some reason.
Nice. There you go. It's back in there somewhere. All those years. Got another question, and I think I know the answer. Does the substrate have an effect for choosing the type of protective coating? Absolutely, yes.
Yeah, Yeah, yeah. I mean,
Type of coating and the environment it's going into.
yeah. I mean, look at talking about concrete. Concrete and all its chemical properties is going to require a different, for lack of a better term, primer application than you would for steel.
Yep.
You don't got to worry about pH or alkalinity or stuff like that. Wood, you're not going to put a zinc primer on wood.
Yeah.
A lot of these mid coats and top coats are interchangeable once you get your base layers down. But most definitely, I mean, and any great coating company is going to be able to walk you through that fairly quickly. But yeah, not all first coats are made similar. So most definitely, the substrate is going to determine, what primer theoretically you're going to put on. Yeah.
Gotcha. All right, hang in there, folks. He's got one more slide, and then we'll wrap this thing up. So there you go, adhesion testing.
All right, adhesion. Some people love adhesion testing. Other people know that you're probably coming up against an issue if you're pulling this thing out. What I mean by that is, a lot of times when you have premature coating failure, whatever it's rusting, peeling, falling off, you're going to run adhesion testing around that problem area. Another thing that people do, if you're an inspection firm or a consulting firm, and Mr. Water Tank owner comes out and says, "Hey, I want to repaint my water tanks. What do I do?" Meaning, typically you're gonna, you know, either overcoat that system, meaning clean it, and apply coating right over top of it, or you're gonna have to go down the road of removing that coating system. So what a lot of individuals will do, they'll run a multitude of adhesion tests to gauge the strength of the existing coating system. That's basically what you're doing. Whether or not you're dealing with a failure or repainting something, you just want to kind of figure out what's going on there at the surface. Okay. So common terms, adhesive, that's the strength of the system or the bond to one another and the surface. Cohesive, that's when you're talking about the ability of each layer to hold itself together. Then glue, that's typically what you use to adhere your dollies down. It's the cohesion of the system. Hopefully, you want it to exceed the strength of the glue used to attach the dolly or stub. Typical standards that you're going to hear: D3359, that's going to be your adhesion by tape test, uh, typically called crosshatch test. And you get the far left there, you see your little piece of Permacell tape. I forget what it's actually called now. I guess they just call it adhesion tape. Um, D6677, a little couple slides over, that's called knife adhesion. It's basically when you cut an X in a system and you're gonna pick at the intersections, and basically you kind of judge and see how hard the coating is adhering. D4541, that's going to be your steel dollies. It's going to go from 10 to 14 mil dollies on pipes, lower diameter ODs, up to 20 millimeters for most applications. That's when you adhere the dolly to the surface, and then you use the adhesion tester to pull the dolly from the surface. And then simply D7234, that's exactly what we just talked about, but you're using 50 millimeter dollies on concrete systems. Okay. So that in and of itself is the main adhesion tools out there for the industry. Don't really care what industry it is, whether it's automotive, industrial, aerospace. They all use the same test to check their adhesion.
Nice.
Any questions on adhesion here?
Yeah, nothing has come in. Good stuff, Matt. I appreciate it. Flip to the next slide. I got your email in there. If anyone has any questions, feel free to contact Matt directly. His email's there. Or you can hit reply on any of the automated marketing messages you receive. It'll come to me or someone on my team, and we'll get that to Matt or one of our experts. Thank you for joining us. Thank you, Matt, for your expertise. It was lot of good stuff here. Keep in mind the recording's going to come over to you as soon as we end this, so you can rewatch it and or listen to it, whichever you like, and share it with colleagues. Also, I did put in the chat if you have more questions or information and just want to do some browsing. I put a couple links to our websites. BYK-instruments.com. That has a section on physical testing, as well as our color and appearance stuff. Also, our sister company, GuardCode, GARDCO.com. You can take a look there. That has all kinds of physical test equipment and fun things. So take a look there. And appreciate your time and thank you. Hope you learned something, and we look forward to seeing you on a future BIC Instruments webinar. Thanks, everyone.